Hi all, how are you? Hope you are all doing well. And I'm Nitish Goyal, and welcome to Machine Learning for Analytics. Today in this tutorial, we will be discussing about Introduction to NumPy. So, why NumPy? So, instead of jumping to the topic NumPy, let's discuss something else. If we talk about images, music streams, and any kind of data that is stored in our systems or in our mobile phones, what do you think how they are stored? Or in what format they are stored? In general, they are all numbers, nothing more than that. For example, if we talk about images, they are just matrices having the values ranging from 0 to 255. And if we are overlapping three matrices, then we are getting RGB colors. That is a colorful image. And that is if we are single matrix, a 2D array, then it is a grayscale image. And if we talk about music, it is also an array of numbers, or at the ground level in the machine, they are all stored in the form of 0 or 1, that is bit values, machine values. So, what do you think how the machine access all those data and do all the manipulation in the backend? You guessed it right. All the operations are in the backend are done on the basis of array. Everything is an array in our system. Or that array can be in the form of a list or a NumPy array or anything you can guess. At the ground level, they are all just array, nothing more than that. And this brings to us to NumPy. As we have spoken, that everything is just numbers and everything is just an array. So how do we process them in Python? For the best, for that, the best library is NumPy. And while working on data science and machine learning, so what do you think we will be dealing with? Of course, numbers, lots of numbers and lots of data analysis over that. It could be string values as well at some point. However, most of them will be numbers. Even if we talk about image recognition and time series analysis of anything, all of them will be numbers and NumPy will be key to them. And what do we mean by NumPy? NumPy stands for numerical Python. It helps us in doing a lot of operations efficiently, saving a lot of storage and power of our system. That is the beauty of NumPy. So let's start with the introduction of NumPy, or how we should be using it in our general life. First comes importing the NumPy library in Python. As you can see, we just have to write the NumPy, that is import NumPy as NP. One point to note over here is that NP is one of the standards that is used globally as an alias for NumPy library in Python. So try to use that on daily basis or whenever you are doing the coding. So first step is done, that is import NumPy as NP. Now NP, we have created an alias with the help of which we will be calling all different functions of NumPy. Or I can say for accessing all the inbuilt functions of NumPy, we create an alias for that is NP here. And if you want to go through the documentation of NumPy, you can simply write this NP and after that a question mark. It will display you the complete documentation of that particular library. In our case, it is NumPy. It could be pandas as well. Then you can say import pandas as PD, then PD question mark. It will show you the documentation of pandas. So in this manner, you can, whenever you need a documentation, you can just go through like this. So jumping onto the arrays of NumPy, or how we can use different kind of inbuilt functionalities of NumPy. First comes creating a zeros array. Have you ever thought of creating an array of any size having the default value 0? I think you may have thought many times. So one of the easiest way to do so in NumPy is simply write np.zeros and number of elements in the bracket. In my case, I'm making it 8, so it will create an array of 8 elements, all values having 0 value. Secondly, going to the next one, this was for zeros, now for the ones. Sim as the word says, ones. All you have to do is write np.ones and then again number of elements. Voila, you have your array. So as you can see that NumPy is very easy to use. Nothing difficult. Even the words in the functionalities, even the function names are very common and they are easy to remember. So not an issue at all. So far we have created a single array, or I must say a one-dimensional array. So you may be thinking that is nothing special. How shall we proceed with a 2D array? It is also simple. For a ones array or zeros array, you can just write the same function, and instead of writing the number of elements in that array directly, add one more bracket, and in that bracket provide number of rows, then number of columns. In our case, the number of rows are 8 and number of columns are 5. So let's try to run it and get our matrix. As you can see, we have got 8 rows and 5 columns. So that is the easiest trick in the Python, or I would say the NumPy. Now, this was for ones and zeros. What about other values? That is also very easy to do here. All you have to do is use a function called full. Like filling a glass, you say the glass is full. Similarly, you are creating an array having the value, any value that you want. You are saying full, complete the array, that is fill the array. So just simply use np.full, then size of the matrix, or the two-dimensional array, 4 rows, 4 columns, and we are putting the value 2.345 over here, and this gives us the required array. Coming to the next topic, create an array filled with a sequence of numbers. Suppose you want to create a sequential array. What will you do then? The answer is pretty easy. You say arrange the numbers, right? And same is the function name over here. np.arrange. It will arrange your numbers from 10 to 25. If you have studied sets in your life, you must be remembering that we always used to include the ground value, that is the lowest value, and all the values between both values and excluding the last one. So same case is the here. It provides us an array having the values from 10 to 24, not 25. Keep in mind that we are excluding the last value. And if we want to include the 25, we just increase that number by 1. And here it is. Next topic in our array is NumPy arrays is step. What is step function or the step variable over here? And why when I'm talking about steps? We are not walking over here and there. Actually, that is the case in NumPy arrays. You can walk or either jump from one value to another. For example, you are given this array 10 to 25, and if you want to print 10, 12, 14, 16, 18, 20, that is an array skipping one value or skipping one step. Or you can say after 10 I took one step and reached another value. Then again I took one step and reached my next value. If you want such values, so it will include two steps. After 10, I skipped one step, second step, 13, 14, two steps, that is. And after 14, if I want to go to 16, step 1, step 2. And 16 to 18, step 1, step 2. Similarly, step variable or the parameter works in the NumPy. Now let's see with an example. Here we are using the same function arrange that will create a sequential order from 10 to 25, excluding 25, and see we are providing a step of 2. And let's click it. And just like we said, 10, 11th is step 1, and then we on step 2 we got the 12, and so on. What if we provide the step value equals to 1? Mm, I think you guessed it by now. It will provide the standard sequence. It is 10, 11, 12, and 13, because 11 is just one step away from 10. Simple as that. Can step value be 0? No, you cannot provide the step value 0. There is a reason for that. Let's learn that reason by running this example. As you can see, we are getting an array 0 by division, division by 0. So the reason for that is, at some point, NumPy calculates that how many elements should be there in our array. That is calculated by total number of elements divided by this. So simply we cannot divide that by 0. So due to which we cannot add the value 0. And just to correct that, I would say we use absolute value of this step value. Now you would be thinking why it said absolute value. Because a step value can be negative. What if I put this step value as -1 or -2? What do you think will happen? Let's learn that. So here is our first example. It provided me an array in the reverse order. But one thing to note over here is that I have swapped these values. That is 25 is I'm providing larger number at first and smaller number at second level. And if we go for -2, it provided me a reverse array. And another thing to note over here is we are excluding 10 now and including 25. Now you would be thinking, what if we provide a standard value like 10, then 25, and then -1 or -2 over here? Do you think we will get any result for that? Because nothing is smaller than 10. So let's test it with our example. Well, you can see we got nothing over here. Reason for that is simple. The smallest value is 10 and we are going to the max value of 25. That is a sequence from 10 to 25. However, we are providing a step value of -1. So we cannot go below 10 over here. That is why we get an empty array. And just to summarize one more thing, I said absolute value. This is the reason. Again, -2. If it wouldn't have been taking absolute value, this number of elements in an array would have been negative. So that would be an error for NumPy. Just to prevent that, NumPy internally takes its absolute value. Linspace, as the name suggests, provides us an array converting all our numbers in equally spaced values. What I mean that, does this sound a little bit confusing? So let's come again at that with an example. Let's say we have a value, min value is 0, max value is 10, and we are providing a size, or you can say how many by into how many intervals we want this series to be divided into, or this gap divided into how many equal parts. That is, you guessed right, 0, 2.5, 5, 7.5, 10. So 0 to 10, this complete gap is divided into 5 equal parts, each having a difference of 2.5 over here. So this is our final error for that. It is very useful while doing data analysis, because sometimes we end up with few problems where we have to create such arrays. So guys, this is it for this tutorial, and we will be covering a lot in the next one, and we'll be deep diving into the more of NumPy arrays and some more inbuilt functionalities of arrays and we will be showing you that how efficient NumPy array is over a standard array or over a standard loops. You will get to learn a lot about that. Stay tuned, keep learning, keep practicing. Thank you very much.